E-Town always talks about being a college where they educate for service, and that's one of the things that drew me to wanting to work here from the beginning. This project is all focused around the EPA's goal of helping people and the planet, and also promoting prosperity. And so I think that aligns really well with E-Town's values, in that through this project we really get to teach our students how to take their knowledge in chemistry and engineering and kind of like their book knowledge and get to apply it.
What we're trying to do is create a simple, inexpensive device that consumers can use to test their water for lead.
So what we've been using in 3D printing is a PLA, which is a polylactic acid filament that is composed of corn and algae, which makes it biodegradable. And then the algae that's used is nuisance algae, so it's helping fisheries and like bays to get rid of that environmental problem.
I guess what inspired me to work on this project is, well, I actually live in an underserved community, so I definitely understand, you know, when you move into a new house, the last thing you really care about is checking your pipes for lead in it. Like, all you care about is having a roof over your head.
You know, it's a right for people to have clean, safe drinking water. And if this is a way that we can contribute to people having some agency in knowing what's going on with their tap water and then be able to take corrective action, like, we're happy to serve in that capacity.
Our test works by taking a paper strip that's made of nitrocellulose, and sometimes I'll call that the membrane, and that's the heart of the test. But on either end of that strip we have something that we call a sample pad, and then something else that we call an absorbent pad. And so when we actually perform the test, you add your sample, your water sample, to the sample pad, and it flows through the strip to the absorbent pad. And so as it's flowing down the strip, it crosses two different lines. And in our case, each of those lines are made of nanoparticles. And so we have one nanoparticle that we will call the test nanoparticle. And this is the nanoparticle that responds to lead. And so if lead is in your water, that nanoparticle will change color from kind of like a clear light yellow color to orange. And then we have a second particle that we call the control particle. And this particle responds to the pH of water. And so as long as the water sample is flowing down the strip, this nanoparticle should turn blue. And so as your water is flowing down the strip, we have the potential to see two lines. And so when you do see two lines, that test line and the control line, then that indicates that your water is positive for lead.
Having this device available and having the EPA know about and help fund it so people know that it is approved and that it actually works could really bring a lot of security to people who need it.
If people are able to use this assay within their homes and able to say, like, yes, I have lead, or yes, I have mercury in my water, then that could be the next step as to how they could find other resources or other ways to actually fix this issue within their homes.